All right, Chapter 8, Section 2, problem number 11. All right, so hypothesis testing. We need to be figuring out the null hypothesis and alternative hypothesis. We have the 5-step process to go through for doing hypothesis testing, so we'll be following that. Let's go ahead and look at this problem and see where we get to. The average household size in a certain region several years ago was 3.14 persons. So pi, how about that? But in this case, this will be our I'm going to get my thing working here. So our mu naught 3.14 persons. The sociologist wishes to test at the 5% significance level. So we have 5% level of significance. I'll just go L of S. So alpha equals 0.05. And whether it's different now. So different, so not less or more, just different, so equal or different, so we have equal and not equal. Perform the test using the information collected by the sociologist, a random sample of 75 households. So we're going to compare the null hypothesis that the average household size is 3.14 persons with this sample that had a sample size of 75, the average. So from that sample, x bar equals 2.98, and that sample standard deviation is 0.82. Okay, so our first step is determining the null hypothesis and our alternative hypothesis. So I guess we'll do that right here. One, our null hypothesis is that the average is the same, that our x bar from the sample equals the average from the household average from several years ago. Alternative hypothesis is that mu naught is not equal to x bar. Alrighty. Second step, then, now that we know that, we need to determine the test statistics. So what's going on here in terms of what information do we have, what values do we have, what's the sample size, is this something that's standard normal, do we have the actual population standard deviation or just the sample standard deviation. Looking at those things gets us to look at the particular test statistic we're looking at. In this case, our standard deviation is unknown, so we use the test statistic of z being x bar minus our average of the null hypothesis divided by the standard deviation of the sample size divided by the square root of the sample size. Okay, so next, step 3, we actually are going to calculate out this information. Before I do that, let's kind of look at our problem here again. So since we're looking at an average, and we're going to look at the standard normal for that one, we'll do the transformation from our current back to the standard normal. And what we're looking at is finding, what areas out here in our standard normal are have 2.5% of the probability on either half. And 2.5 on either half adds up to 5 across the whole, which gets us back to our alpha of 0.05. Then we can look at it where we have a two-tail test because we're looking at both the upper and the lower because it's different. And that's where we're headed with this one. Okay, so then what we're going to come up with is when we're looking down here, we'll find the value, the z value here, and the z value at this point, and then compare the z value we create from the test statistic, which we have back over there on the left side of the page in number 2, and we'll compare that z with our z at alpha over 2 minus, and our z at alpha over 2 on the plus side. So that's where we're headed. We'll compare those. All right, so our test statistic, we have z equals x bar, which we had was 2.98, minus the average of our null hypothesis, the null mean, which was 3.14, And that's going to be divided by our standard deviation of our sample, 3.82, divided by the square root of our sample size. This is going to be minus 0.16 divided by, if we work that out, that should be 0.0947, which gives us minus 1.69. Okay, so we're going to compare that here when we have our alpha over 2. Let's continue working that one here. So essentially, if I go down and say in step 4, I'm going to do that right here. So step 4, this will be minus z of alpha over 2. So the alpha over 2 is going to be that we had alpha of 0.05, so over 2 is 0.025. Z of 0.025. Over here we have the plus side of z of 0.025. And again, the z-value that we can look at inside the cumulative table to see what z-value gives us the 0.025 inside the table, or we can use the t-distribution with the degrees of freedom at infinity at t of 0.025, which is the way I did it, because we can pull the number directly off the t-distribution for that. And so this will be a minus 1.960 or a plus 1.960. So essentially our interval is from minus infinity up to minus 1.960, or from 1.960 out to positive infinity. In other words, all this area or all that area. Great, so we go down to number 5. What we're going to do is compare our z statistic that we calculated in number 3, so the actual value that we're looking at for this sample. So the z there was minus 1.69, so our minus 1.69 falls in this area. So it does not fall inside the rejection zone, so we don't have enough information to reject. So our z is not, let's fix that. It's not in rejection region. So therefore, our current sample does not reject the null hypothesis that the means are different. So mu naught being equal to x bar. Thus, I guess we should say that instead of thus, say that at the 5% level of significance. It's not reject. Okay.